Hello grade 12s, welcome to this lesson where we'll be learning how to sketch a cubic graph from a list of given properties. At the end of this video, there will be a bonus question that you don't want to miss, so stay tuned. Let us look at the first question that we need to answer in this lesson. Here it is. Good. So we're given 4 properties that we need to read, analyze, and interpret so that we can produce the correct sketch for this cubic graph. Let us start with the first property that is given. F of x has exactly one real root. That just tells us that the graph of f has one x-intercept. You recall that roots are x-intercepts. So we have taken care of that guy. Second bullet point, f of 4 is equal to 30. What does that give us? It gives us a point. And I've already sketched the frame of reference here for us, the Cartesian plane, and there's our point. F of 4 is equal to 30. Next point, f of 0 is equal to negative 40. So that is a y-intercept because your x-coordinate is equal to 0. X-coordinate is equal to 0 with your point. It's right there at negative 40 there on the y-axis. So we have indicated the 2 points there. The third bullet point talks about the first derivative of f. And it says the first derivative of f evaluated at 4 is equal to 0. What does that give us an idea of? Stationary points. F is either at the local maximum or at the local minimum or the point of inflection when x is equal to 4. Which one will it be? Let's look at the last bullet point. The second derivative of f evaluated at 4 is equal to 0. So f is definitely the point of inflection. The concavity is changing there, and we need to now use all this information to sketch the cubic graph. How would it look like? So by the looks of things, it will cut the y-axis there, the y-intercept, go all the way to the point of inflection, change concavity, and go to infinity. Right, so let us sketch it. And that is a possible orientation of the cubic graph. And there you go. Let's now move on to the bonus question. How does it look like? Like this. All right, so we're given 2 equations and we're asked to solve for a and c, those 2 variables. Now, what do we see? This is a rational function, it's a rational function. However, can we simplify? Yes, we can write f of x like this. If you split into 3 fractions, you divide x into all the terms into your numerator, you get ax plus 5 plus c x to the power negative 1. So you prepared for differentiation. This one, you can split it again and write it in terms of 2 fractions. So x over x squared, that's 1 minus 3x to the power negative 2. Okay, so let us differentiate our function f. What do we get? A minus c x to the power negative 2. Compare your expressions that represents your derivative. Okay, so therefore we know that a is equal to 1 or c is equal to what? 3. Done. Those who are slightly a bit more advanced can use what is called the quotient rule for differentiation. How? We can look at this as a function called g of x, and this can be a function called h of x. Okay? So then what do we do? The quotient rule says f prime of x will be g prime of x times h of x minus h of x, or the first derivative of h, times g of x over, in this case, your denominator is the function h of x, and then you square it. Let us test the rule and see if it will definitely give us the answer. Okay, what is this telling us? Differentiate the function g. If you differentiate your numerator with respect to x, you get 2a x plus 5. Right, and the c is a constant, it will fall away. And you multiply this with h of x. What is h of x? Is x minus the derivative of h of x. What is it? 1. Okay. You multiply this with your g of x, ax squared plus f of x plus c. Okay. This is over what? The square of your h of x. In this case, it's x, you square that. Do you see how it leads us to where we are going to? Yes? Let's clean up. We're going to have 2ax squared plus 5x. Okay, clean up that side. Minus ax squared minus 5x minus c all over what? X squared. 2ax squared minus ax squared is equal to ax squared. 5x minus 5x falls away. You are left with minus c over x squared. Okay, you compare this to the given expression that represents the derivative, you will arrive at the same result. A is equal to 1 and c is equal to 3. Okay, so actually this should be and that also must be and. Sorry about that. But yeah, interesting, right? Harmony in mathematics, we see it right here. So there you go in terms of the bonus question, and definitely it has enriched your skills under differentiation, and you may use it if you want to use it and learn it. And yeah, from here on, I believe that takes care then of this lesson, and it's really up to you now to go out there and excel. Thank you for tuning in. Sharp, sharp.